Hi all, in this video we will go over the normal force between three masses pushed along. So we start off and we have a flat horizontal surface where we have three masses. This is M1, this is M2, and this is M3. That we're given that these are all accelerating to the right with an acceleration A. First part asks, what are the given quantities? So the given quantities are the three masses and the acceleration A. So M1, M2, M3, and A. B says sketch a force diagram for each mass. So for these masses to be accelerating to the right, there needs to be a force applied somewhere. Let's say that it is on the left mass. So there's going to be some force F, capital F there. So for mass 1, we'll treat it as a point mass. We'll have F moving to the right, and then if M1 is pushing up against M2, then it is pushing back on M1, and the notes called that force N1. And the acceleration is to the right, so that means that anything pointing to the right is positive. For mass 2, treat as a point mass, we have, by Newton's third law, an N1. So Newton's third law is that forces in an interaction come with equal and opposite pairs. So there was an interaction force here from mass 2 onto mass 1, so there had to be a force on mass 1 acting on mass 2. Then mass 2 is acting on mass 3, so there has to be another normal force. So we'll call that N2. And once again, this has acceleration to the right. And 3, we have N2 acting to the right, and this isn't butting up against anything. So these are our force diagrams. So there is only a force acting to the right because there's only an interaction right here. There is no interaction over here, so it doesn't have anything else left to give. So the next part is write down, this was B, C, write down Newton's second law for each mass. So we'll say M1A1 equals 2, and we'll look at this. We said to the right was positive, so we're going to have a positive F, and then a negative N1. We'll have an M2A2. We have a positive N1, N1's pointing to the right, and then we have N2 pointing to the left. And over here, we'll have an M3A3, and then that means, so we only have N2 pointing to the right, so all we have is a positive N2. D, what are the constraints? So in part C, you only ever write down A1, A2, A3, dumb to the fact of anything else, and D will make constraints. So our constraint, which was given, is that A1 equals A2 equals A3 equal to A. So over here, we could just rewrite these as this. So now we have M1A, M2A, M3A. Those equal to the vector sum of the forces over here. So the next thing is part E wants to know what the external force F is. So what we can do is we can just simply add all of these up. So this F is going to stay there. We have a minus N1 and a positive N1 here, so those are going to cancel. We have a minus N2 and an N2 there, so that's going to cancel. So we're just going to end up with F on the right, and then it's just going to be M1A plus M2A plus M3A. You can factor that out. So we get M1 plus M2 plus M3, all of that, times A equals to F. So this is very key on this side. So I feel like everyone's going to get this easy. It's just M1A plus M2A plus M3A. So that ends up there. Here, there is only a positive f, and none of the other sides have an f. There's a minus n1 and a positive n1 here, so when you add those together, they'll cancel each other out. And then same thing happens here. There's a minus n2 and a positive n2 over here. We're just left with that. So this is what the force F is. And then part F asks, what is the force exerted by mass 2 on mass 3? So we want to know what N2 is, and since M3 and A are givens, we can just represent that as this. N2 is equal to M3A. Since both of these are given, that's perfectly acceptable. And then we want to know what the force exerted by mass 1 and mass 2 is. So now we have to find what N1 was. So we'll just clear everything up. We will start by saying that M2A is equal to N1 minus N2. That was one of the equations that we had. And we already know what N2 is, so we can just swing this over to here. So we'll get N1 equals to M2A plus N2. And we'll get N1 equals to M2A plus M3A. And we can just rewrite this as N1 is equal to M2 plus M3 times A. So that's G. And then H is just what is the net force on M2. So the net force on Newton on M2 is just N1 minus M2. So it'll just be M2A equals to, well, yeah, that's all that is right here. We could rewrite it a different way, but we already knew that. This was sort of just a definitional thing. All right. Thank you very much.